Hi everyone, in this tutorial I am going to show you how you can generate and visualize confusion matrix. So let's quickly look at this Wikipedia page here that explains what the confusion matrix is. So confusion matrix is an evaluation method and it is used to evaluate performance of machine learning or classification tasks. Let me put it that way. So if you have a machine learning model that you have built, then you can evaluate its performance using confusion matrix. So you can read more about this. The details are all here, but let's look at it. Confusion matrix, basically what it does is to compare the actual outcomes or the true labels of your data sets to the ones predicted by the model. So if you take a look at this one here, for example, we have the actual labels or class here, and then your machine learning model makes this prediction here. So confusion matrix will now be used to compare this one here and then the predicted ones here, and then based on the outcomes and what you get, you'll be able to evaluate the performance of your model. So that is what we are going to do in this tutorial. So without further ado, let's go to the Python interface and continue from there. So what you need for this tutorial is just an internet browser. You only need your internet browser and then an internet connection. That is all that you need. So you'll use the Google Colab platform, and this is it. So I'll go to this page here, which I'll click and visit. And I'll also leave the link to this Google Colab page in the description box so that you can use that. So when you visit it, you have this coming up. But please also make sure that you have already signed into your Google account because that is a requirement to use Google Colab. So once you have this, just click outside here and then you have the interface being shown for you. So what we are going to do first is to generate a confusion matrix, and you go to File, New Notebook, and then we just do a demo here. So we are first going to import the confusion matrix function in scikit-learn, and we do that. Make sure you have the code selected. So we say from sklearn.metrics import confusion matrix. There's an underscore here, and then run this code. So after you have run this code, then we now proceed to generate some dummy outputs. That's what we are going to use for this, just for you to understand what the entire process is about. So if the code is successfully executed, you have this green tick also shown here, which is fine for us. So let's add another code line here. We are going to use our own outcomes here. So this will serve as the true outcomes. So we say 0, 0, 1, 1, 0, 1, 1, 0. So we have our actual outcome here. So let's create this by running the code here. Let's create another code that will give us the predicted. So we assume that the model has also done its prediction. So there's the prediction here, the classes. And we should have this here. That's it. So this is what we have. So let's run this as well. So we have the two. So if you are doing a classification task, then you need to make sure you have your actual outcomes and then your predicted outcomes, and then you'll be able to generate and visualize the confusion matrix. So let's add another code here where we call the confusion matrix and we specify the actual outcomes and then the predicted outcomes, which are the classes. So let's run this. And then we have our confusion matrix generated for us. But what we have here, we'll be able to understand it. We can better understand it if we visualize it. And that is what we are going to do next. So this section was just to let you know what you need in order to generate the confusion matrix. So the next one, what we are going to do is to use the code here in scikit-learn here. It's based on this code here that we are going to generate the confusion matrix. So I just thought I'll let you know. So let's go back to the Google Colab here. Let's go to a new one. Yeah, let's come back here. So what we are going to do is to run the notebook, which is in this GitHub repository, this particular notebook here. So Google Colab allows you to run Python notebooks from GitHub. And I have a separate video that goes into details with that, so you can watch that later on. So you also need to make sure you have the link to the user account here, which is this one here. I will leave the link in the description box so you can also try that. So first of all, you go to File, and then you go to Open Notebook. And then once you are here, you go to GitHub, and then you paste the notebook link there. That's the GitHub user link here, and then you search here. So once you search and it's successful, you have the repos being displayed. So here, you use this arrow here. You scroll down to the machine learning tutorials, and then once you're done, you search for evaluation/confusion matrix using dummy data. That's what you need. So you click on it, and then it will be opened for you. So with this one, you don't need to write your own codes. We just run these codes here. So the codes are the ones also here. So what this codes is doing is that it first generates a dummy data set for classification, and then splits, and then we call the classifier, and then finally we generate the confusion matrix here. We visualize it. Let me put it that way. So first of all, we import the libraries we need, which are here. You have this warning, but you can ignore it and run anyway. And then you wait for the code to run. So if it's successful, you will have this green tick also being displayed there for you. So just do it that way. So we now generate, after importing the libraries here, we now generate our dummy data sets. So scikit-learn allows you to generate your own data sets for classification tasks. So this is a dummy data set, or you can say synthetic data sets. So we've generated it, and then we split the data into train and test sets by running this code here. So the training sets is to enable the model to learn and identify patterns that can then be used to make future predictions. So we do that. So after getting the data splits, we now create the classifier. In this case, we use the support vector machines, and then we now feed it with the training subsets, and that's what we have with these two statements here. So training is done. So we now generate and then plot the confusion matrix. That's what we are going to do next, and I will explain it. So let's run this, and then you have your confusion matrix and being visualized for you. So with this visualization, it's easy to explain and also understand your output. So that's what we are going to do. So with the confusion matrix, we have the true label and we also have the predicted label. And so we use this to have an idea of how many of the samples were predicted correctly. So let's look at the label one here. Okay, so this one class, this is another class. So we have two classes here, making this activity a binary classification. So let's look at label one here. Let's look at label one here. We have 10. So this 10 here means that 10 samples had, they were originally belonging to the label one, which is one of the classes. And then the model here also predicted those samples or those data points also as belonging to label one. So in other words, these are correctly classified samples. So we have 10 of them here. Now when we come here, we have two here. So these two here originally belong to label one, but they were classified as label 2 by the model. That is what this um, value here means. So this means that there was misclassification. And there are a number of reasons why models can misclassify some samples. And it could be that during the data collection process, those data points were originally not belonging to that label. So probably it's a human error. That's why we have it there. Or there could be other factors, but that is beyond the scope of this tutorial. So the point here is that here there were two misclassifications here. That's what it means. But if you compare, majority of them were classified correctly, and that's what we have here. Let's look at this one also here. We have label 2 and then we also have label 1 here. So this here is similar to this explanation here. So it means that we had this label 2 and then two of them were misclassified. They were classified as label 1, but that's not what they actually are. So here it's also a misclassification. But when we come here, we have 11 samples here which were originally label 2, and then the model also predicted them to belong to label 2. So here is a correct prediction or correct classification. So that is how we interpret the confusion matrix. So using this, we're able to tell the performance of the model by identifying those that were predicted correctly by the model. So that is how we explain the confusion matrix. Of course, what we did here is binary classification, but we can also have confusion matrix for multi-class classification. That will be done in the subsequent videos. So what we did here, we use a dummy data set here, but then in this same GitHub repository, there is a data set that is real world and was even published, and then that was used to make another tutorial. So you can use that to also get to learn more about confusion matrix, because that notebook allows you to run those commands and evaluate some of the models with confusion matrix. So let me quickly show you that one before we end the tutorial. I wouldn't go into details, just to show you how. So the same repo, let's go back here. Let me open a new one here. Google Colab. So that notebook is here, and you can use that to also begin learning about machine learning. So you go to machine learning tutorials, and then you select machine learning for predicting malaria using hematological data. That's this one. And I have a separate video that also explains all the codes in this particular notebook. So you can watch that and then just try to understand more about machine learning. So that'll be all for this tutorial, and I hope to see you in the next session. So you can also post your comment below and we can discuss what we've done so far. So see you in the next video. Goodbye.